We're gonna record it. Okay. Where did I leave off? Where was I? Sorry, I remember the website. Yes, they'll take it to the master website. From there, you can go. This is for any semester at 1553 stuff. He has a bunch on there, and then go to the master website. Top, you should see these tabs. One of them should say calendar. Find the calendar. Scroll down until you see midterm stuff. There should be like a whole column of like whatever's. Like I know for last semester, at least, he posted the actual exam solutions and stuff like that as well. Very helpful resources. If it's in the same format this semester, you should expect something rather similar. As Dr. Jankowski told me, because I was one of his TAs last year, for any linear algebra exam, as much as you would like to come up with a new question on an exam, it is probably not possible. Probably in some kind of homework, past exam, past supplement, past something rather, that question is there with different numbers or different wording. Okay. Cool. All right. Did you find the website? Yes, this is midterm 1. Yeah. All the content should be the same semester to semester, I believe. Okay. All right, let's move into, yes. Yes, you have to bring your buzz card. If you have lost your buzz card, bring a state ID, okay? This is not because we have to do any kind of weird requirement. This is because we have to make sure you're not hiring someone to come and take your exam for you, because we'll write you up very quickly and you will get in a lot of trouble. So, yeah. Yeah, that's a fun story that I'm not allowed to share. So, all right, so let's.
How do you suggest studying?
At this point, if it was a few weeks ago, I would say start going through some of the lecture slides, start reading some of that stuff, get the content. We got 2 days of the exam. Go through some practice exams. Just start cranking them out. My best advice for that is timing yourself. Save one of those practice exams. Don't touch it. Just take it in an hour and 15 minutes, okay? Or break it up. Like do this question, see how long it takes you to do these questions. One of those. I am. Yeah, I'm all good. Yeah, it's all good. Yeah, thank you so much. Okay. Moving into technical questions. Is there any opposition for me to just go into talking about span and solution set conceptually? Lovely. So I'm going to do that. That'll take a little bit. And then from there, we'll just go straight into actual computation stuff. Okay, cool? Lovely. Okay. So for those of you, also just a note, my email is zbrumbox3@gatech.edu, obviously. And my office hours are tomorrow, 1 to 3 in Polk 255. Sounds right. New room to me, so it's on the campus site. Yes, very nice. Yeah, span solution set. Let's go ahead and into that. Oh, for those of you who are from my studio, they'll hear me say this just about every day in there. The #1 golden rule of linear algebra, especially for this exam, if you have no idea what the hell you're doing, is you look at the equation, you put it in a matrix, and you row reduce it, okay? If you are absolutely lost in some question, all right? If you row reduce it, odds are you're gonna get some amount of points, okay? I'm not saying that should be plan A or B or C, but like, you know, we've been there. Okay, so let's first talk about span. And over here will be solution set. I'll do these individually, and then I'll talk about some of the connections they have. So what is span? Does anybody have a good definition for that or a rigorously mathematical definition for that? Yeah. Yeah, which vectors? Any vectors, right? For this class, for this set of things, I'm gonna write it in matrix notation, AX equals B, okay? What span is saying is it's where can the columns of A reach? Where can those vectors of A reach, okay? So span is where can you get? Okay. And how do we determine the span of something, right? So I'm gonna go through the process of finding the vectors that are most important to it, which may not be as pertinent to this exam, but it's still very essential for understanding the basis of span. Okay, so first, you are given some, let's move on this, matrix A, or vectors, but I'll just say you're given some matrix A, all right? Step 2 would be determine pivots. How do we determine pivots? Row reduce. Okay, so you determined your pivots, right? What do those pivots tell you? That's true. That is true. So it says which variables are not free, is the way I like to say it. Okay. So it tells you which of your columns are linearly independent. Okay. So pivot columns are linearly. What that means is you can't get from any one to any other by any combination of anything. Okay. An easy example of like a couple things that are linearly independent: 1, 0, 0, 0, 1, 0, and 0, 0, 1. There's no combination of any pair of these that gets you to the third, right? Okay. So then you say for span of A equals the span, and you put this little bracket, pivot columns. Okay. So this is more span broad term. What we like to do for this class is the question B is B in span of A. Nope. And how do we solve this? We solve this by setting the augmented matrix A augment with B. Okay. And then from here, if it's consistent, then what? What does that tell us? B is in the span. Okay? It's inconsistent. What does that tell us? B not in span. That makes sense, right? This is more than likely what you'll be tested over for the sake of this, okay? But this other stuff is incredibly important, especially right here, okay? Pivot columns are linearly independent. So that tells you the number of pivots. That number is incredibly essential to determining span, because I can promise they'll ask you some kind of shape of a span, right? And I'll kind of zoom out so y'all can start to see that stuff. So I'll write shape of a span. I like to call it R to the number of pivots in R to the number of rows. Okay. And notice how these are in brackets or little quotes here, because that's technically not right, but that's the way I like to think about it. It's the dimension that it tells us, okay? So we have 2 pivots. What is the shape of our span? Plane. We have 4 pivots. What's the dimension of our span? 4 space. We have 0 pivots. What's our span look like? It's a point. It's 0. Exactly. If we only have 1 pivot, likewise, you can assume that it's a line. That's R to the 1. One-dimensional thing is a line. R to the 2, two-dimensional thing is plane. R to the 5, five-dimensional thing. R to the 0 is a point, zero-dimensional thing. So this is span in a nutshell. Do we have any questions on this? Where? Oh, I'm so sorry. You're just like out of my peripherals. Thank you. So that doesn't pertain to span. What it tells us is the things that don't contribute to the span. Okay. An example of that would be if I have a matrix that looks like, R to the number of, I'll do that in 1 second. So if I have a matrix that looks like this, okay, we'll call it a 3 by 3. Okay, this is our matrix A. How many pivots does this have? 2, okay? So this free variable pertains to solution set. But what it also pertains to in terms of span, we call this, since we called the pivots the linearly independent columns, what do you think we call this one? Linearly dependent, exactly. Because think if I'm drawing in 3 space, right? And I give you something that shoots that way, straight out to the camera, and then straight this way. And I say something else also shoots out this way. None of those add, that last vector doesn't add anything to the shape I've created. It's already on there, it doesn't do anything. It is redundant, exactly. Yeah, so linearly dependent things are redundant. We only think about the pivots are essential parts of the span, okay? Cool. So the relation again there was the shape of a span, R to the number of pivots and R to the number of rows, okay? Because again, think of how your variables in A, right? These are V1, V2, blah, 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 Vn, right? What dimension are each of these vectors in matrix A? If this is M by N. Each of these vectors has what dimension? It's M by 1, right? Because they're each M tall and 1 wide, okay? So it makes sense that our span is talking about where these vectors live in our M, and it constructs whatever space of however many pivots we have, okay? Make sense? Any questions on that? Yeah.
It's more generally about span.
That's fine.
Is the span of A the same thing as the column space of A?
That is exactly correct.
Okay.
So, fun little fact, the whole next exam is going to be over some stuff called column space and null space. Column space is span. Null space is solution set. Okay, different terms, same shit. Okay. Cool. Any more questions about span? Lovely. Ah, okay. Yes, you.
What's the difference between the span of M and the span of N?
So the span of N isn't something we can really say because the span of the variables is our solution set stuff. We only talk about the span of the columns for the, like that's what we talk about as span. It is our column stuff, okay? Does that make sense? Where's that other question? Raise those hands high. I do have glasses. Ah, there we are. Yes, so the shape of a span, think of this on like axes, okay? So on like R2 or a very traditional plane, oh God, where the hell is it? Shapes, X, Y, okay? So here, right, we have a vector that goes like this and a vector that goes like this, and they make up this whole plane, right? Because this has a dimension of 1, or this has a size 1, this has a size 1. For a traditional like coordinate plane, right? Think algebra. All of you hopefully taken algebra at some point, or hopefully more recently. But on a coordinate plane, it's like 1, 2, 3, 4, 5, 6, whatever, right? So these vectors are what build it, right? However many X, however many Y. So these two are linearly independent vectors in the space, okay? So if we just have one of them, right? What is the span of that? The span is the linear combinations. So we can multiply this vector by any number, okay? So let's multiply it by infinity and also negative infinity. And you'll notice that it just takes up that whole axis, right? But as soon as I give you something else that can stick off of it, you can go this way and you can go this way and you can combine them to get everywhere, right? We know that. That's plotting traditional stuff that you can learn in previous. So that's kind of how you can think about shape like that. Most importantly, what to kind of take away is each pivot column corresponds to an added dimension of span, okay? Every extra pivot is one extra dimension of your span. So you have 3 pivots, you have 3-dimensional span. Okay, yes, up there. Yep. So if it asks you if something is in the span, okay, what you do is you solve A, augment B, and going back to here, if it's consistent, it's in the span. If it is inconsistent, it's not. Okay, yeah, cool. Okay, moving on. Yes.
So if you were given, like, create something that has a span in all 3.
Sure.
Then something with a 3 pivots, that all you have.
If it's in R3, then it would have 3 rows. Okay. If it says create something that spans all of R3 for 3 vectors, it means you're going to have 3 pivots in a 3 by 3 matrix, right? Yep, cool. Okay. Okay, moving on to solution sets. So I'm going to write down here. So given AX equals B, row reduce, echelon form, parentheses consistent. Reduce echelon form. Then over here, pivots. And see if consistent. Okay, we'll get back to what this little chart means at the end. Okay, this is the process, like I talked about, to determine if something is in the span. You're given A equals B, you row reduce it, you determine pivots. This is kind of like a little sidebar that's very helpful. And then you see if A on B based on that. You can kind of do these two at the same point. Okay, so moving on to solution set now. Oh, we had a couple questions in chat, didn't we? So pivot columns are linearly independent, correct. And I did the other association as well. Lovely. Okay, solution sets. So over here, this talked about columns. Okay. Here, it's kind of confusing because both do talk about columns and rows, right? But span talks about columns as vectors. Okay. This one talks about columns as variables. Or as we like to think about it, rows as equations. This is the more important thing to think about here. Okay. So solution set. How do we determine a solution set? What is a solution set? It's the ways to solve AX equals B, okay, for some vector X. So over here, we're talking about A. Over here, talking about X, okay? So what's the process to do this? Anyone want to take a guess at what our first step is going to be?
Row reduce.
Row reduce. Wow. Okay, so step 1, row reduce echelon form of A augment B. Also, I didn't prepare any notes for this, so sorry if they're a little inconsistent between span and solution set in terms of order, but what can you do? I'm not getting paid for this, I'm just here to help.
Thank you.
You're welcome. Okay, so we row reduce. So as you can think, we'll talk about pivots before. What are we going to talk about this time? Free variables, also known as not pivots, right? So not pivots. Parentheses, free variable. I just like to say not pivots because it kind of makes sure that you know the connection between the two. You can also think of them as free variables and not free variables. Yeah, so dealer's choice, I guess, but you're going to see free variables on your exam. It's written like that. So you determine on pivots, what you do.
Wait, did you say on exam they'll be written?
No, you'll see free variables. Not pivots is more of a me thing that I prefer. So now parametric vector form. Okay, so we're in parametric vector form. All right. So in parametric vector form, how many vectors do we have? It's equal to what number? Number of free variables, exactly right. Okay, so this, you have the number of free variables. Vectors, why the hell did I blank on that? Number of free variable vectors, okay? So for parametric vector form, we then write it as, I know a little confusing here, but the span of vectors, parametric vector form vectors, plus this little thing that we call VP. How many of you are going to have to take differential equations? Yeah, this right here, this is going to be a pain in the ass to find. But right now it's not. So VP, this exists only if B is not equal to 0. Like here?
Yeah.
Okay, cool. Yeah. So VP exists only if B is non-zero. So if B is 0, what is VP? 0. It is not there, okay? So when you see something, like you probably will in some homework question, I haven't seen the exam. I couldn't even allude to a question if I wanted to. But, gross. But how do we, this right here, what this is like if you have just one free variable, it's going to plot like this. If VP is 0, VP is just a shift. So VP is 2, 0, okay? Then my shifted thing will look like this, okay? Starting at the point 2, 0. This is a shift of the origin to solve for B, okay? Shift of origin, okay? This isn't something you're going to have to worry about much after this exam, but for this exam, it is relevant. And they do like to throw some trick questions in there. I know last year, the last question on the exam was something about this, and maybe 90% of the students missed it. It just happens. Yes?
It's the same thing as that.
And I will do that question, by the way.
Non-trivial.
Yes. So you'll be asked, have this class as terms, right? Because you guys haven't seen that stuff before. So a homogeneous solution is when B is equal to 0, okay? So when B is equal to 0, we don't have to talk about this, okay? That's why we like it. Likewise, for other stuff, we have VP. I think it's a little annoying. And again, I'll work through a problem with that because I know it's gonna come up and I know someone's gonna ask me, or just make sure somebody asks me about the last question on last year's midterm, and we'll do that.
What does VP stand for?
It stands for the particular solution. Yeah, V sub P, the factor that of the particular solution. So like in differential equations, you're going to get this whole crazy thing equal to something. You solve for it to be equal to 0, and then you add the particular part. So, way over the scope of this right now, but just a heads up for those of you that got to take that. Okay, so this right here, that's our solution set. Okay, and what do we say the shape looks like? Solution set, well, comparing it to our span, you can assume it's kind of backwards, right? R to the number of what? Free variables in, anyone want to take a guess? R to the number of columns, right? Because our number of rows is our dimension of our vectors. Our number of columns is how many variables we have. So our solution set talking about variables makes sense to plot it with those variables, okay? Does that make sense? Okay, cool. So questions on solution set, conceptually? Yeah. Yes, so the shape of solution set talks about the variables themselves, right? Oh, I'm so sorry. I didn't realize that was covering that. I don't need to see myself. That's fine. Yeah. So column space or span particularly for now. We talk about it in R to the number of pivots in R to the number of rows. We have that many linearly independent vectors, and each of those vectors has the number of row entries, right? Because they're that tall. That's how many things they have in them. If you have a 4×3 matrix, each of those vectors has 4 entries in them. So they're 4-dimensional vectors, okay? Likewise, this vector X is equal to the number of columns, which is our number of variables if we think in terms of equations, okay? So solution set will be in R to the number of columns, or if you'd rather, to the number of variables. Okay, because we have that many variables and we're plotting the things that can shift accordingly, okay? R to the number of free variables is how many vectors we have to shift along based on how we solve for parametric vector form. All right, any more questions on those? Again, conceptual stuff. We're still gonna go over questions, we're still gonna go through all that stuff, and I'll explain it every step of the way as well. Okay, questions on this? Yeah. You're gonna have to speak up just a little. Yeah, so whenever we have parametric vector form, right, we have something that looks like x vector equals, we'll call it x3, -3, 2, 1, 0, plus x4, 1, 1, 0, 1. And something to note is these vectors will always be linearly independent. You don't have to dwell on that too much, but the way that you can think about it is when we line them up, right? We have like x3 equals x3 for the free variables and x4 equals x4, right? So that means the only entry in the row with x3 is going to be the one tied to it. So it's going to be a pivot. You don't have to think on that too much. That's just a cool little thing that happens. So the moral of that is whatever these vectors are, they're pivot vectors, okay? So x3 and x4 are free, right? What does that mean we can do with them? We can do with whatever we want, right? So if we have two vectors and we can multiply them by whatever we want and add them, what is that? That's the definition of what? Both of those things are true. Span and linear combinations. Those are the same thing, right? So since these are just linear combinations, we say the solution set is equal to the span 2, 1, 0, 1, 1, 0, 1, something like that. Okay, and you'll notice that since this doesn't have b equal to, or this does have b equal to 0, there's no plus anything. Okay, if there was some b vector that was not 0, we'd have some other thing over here that would look like 3, 0, 0, 0, whatever, you know, some set of numbers. So you'd say this plus 3, 0, 0, 0 is what that would look like if b was non-zero. But that's kind of the connection. Solution set becomes a span. Just a little confusing, but solution set talks about our variables. Span talks about our vectors, okay? Yeah.
So what kind of question would they ask for us to give that?
Solve for the solution set of this system. And it's a set of equations, and their equations are equal to things. What are the first two things you should do? Put it in a matrix and then write this, but yeah. You'll see that on some of the practice midterms if you go through them. But this form here is totally fine. You don't have to write this. This is redundant. Yeah.
So you add the, if you have like a separate constant vector on the solution set, would you actually expand?
Say that one more time.
If you had a constant vector, right?
Yes.
Like it's not going to
Yep. Yeah. So it's like a plus 3, 0, 0, 0. Yeah. So what that becomes is, oh God, I don't want to plot in 4 space. We'll pretend it's in 2 space. Okay. So let's say our solution set looks like this. Okay. And that extra VP is equal to 2, 3. Okay. So what I do is I count 2, 3. Okay. And I start a little point. Okay. So this is the span of whatever vector plus this now. Okay. So we go here and we start that same span with the same vectors building out from it. Okay. So a thing to note is each B will have its unique solution set. That's a thing that happens as a result of this. Okay. Every time you change B, this line is going to move somewhere that is unique. Okay. Yeah.
It's putting whenever you get the parametric form
Yep.
of the equation, is that always going to give you the span?
It will always give you a solution set, which is the span, but we call it solution set. So yes, go to parametric vector form, you have your solution set. Yeah.
What was the name of the guy with all this?
Jankowski. Jankowski.
Can you say that for us?
Jankowski. Yeah.
For the like other export, what was the dimension?
Yeah, so how many free variables do we have? 2, right? So what would the dimension of, what is the dimension of the solution set? Great. We have 2. So it's R the number of free variables and R the number of columns. So we don't know the number of columns, but yes, we do. We have 4 variables total, right? That's what each row corresponds to in parametric vector form, right? So this would be a plane or a 2-dimensional thing in R4 is what the shape of this would be, okay? And if you had a plus constant part, it would be a shifted plane in R4.
Yeah.
Yes.
So I get the formatting for writing like the 300, like
sure.
If it's translated for solution set, how would we write? How would the formatting look first if you had to do it first?
You will not have to do it for span.
Oh, because
span doesn't have anything to do with B, right? We can ask the question: is B in A in the span of A? But to have, oh, sorry, I should have started with this. To have a solution set, AX equals B must be consistent. That is a must, okay? So here, if consistent, parametric vector form, and there you have your solution set. This is our little chart, the way that I like to do to solve these questions, okay? Or some variation of it. I did one in Studio, but it wasn't quite the same, I don't think. Yes.
Do you use parametric vector form if you have one?
If you have one unique solution, then what does your parametric vector form look like? How many free variables do you have? 0. So what does your solution set look like? R to the 0, which is a point, and R to the number of columns, right? So that span isn't really a thing. It's just the 0 vector or some shit of that point. So the actual big picture connection between span and solution set, I'll get to in a second, is a little confusing to think about, okay? But what you don't have to remember everything I'm about to tell you, but this is just a good way for some people think about it. Span tells us if we can get somewhere. Okay, solution set tells us how we can get there, okay? If our solution set is a line in R4, we can pick any point on that line, get to B, okay? But span will only tell us if it's in B, okay? Cool, yes, we had a question. Number of free variables tells you the shape. Well, this is free variables tells you the shape of solution set. Okay. Not free variables or pivots tells you the shape of span, right? Truly, if you remember anything from this, these 2 things will definitely be asked. The shape, okay? Yes. Yeah, go for it.
A span is basically how you break the entire group. That's just the vector.
That is correct.
And the solution set is if that specific B is within the span.
The B is if B is within the span, what do our variables have to be to get there? So like, because x1, x2, x3, x4 are like the things that are in front of our vectors, right? So like here, we would pick our x1, x2, x3, or sorry, our x3, x4 to get an x1, x2 as well, to then plug those in and get to the B. Those are like directions. That's how you can think of it. And the way I like to think about it is you can overshoot something and still come back, right? That's the idea of infinitely many solutions. You can end up over here and still retract, or you can go over here, and that's for like infinitely many solutions. There's infinitely many ways to get there with those steps. Okay. Yeah.
So basically, span is all possible answers, and then you use the solution set to find
Yes.
what the variable.
Span is all possible answers, and solution set tells us our particular ways to get there. Cool. We spent a lot of time on this. I'm going to go ahead and move into some questions. So who has examples and stuff they want to talk about? Yeah.
So have the matrix A equal to
Columns, these are columns, not rows. Okay. 1, 2, -1. Okay. So the span, when we row reduce this, what you're going to find is it's 1, 0, 0, 0, 0, 0. How many pivots does it have? 1. How many rows does it have? What was that? Yeah, it's a line in R3 from that, right? Single pivot, 3 rows. So it is a line in R3. Cool. And the reason I can tell that there was a pivot there so fast is because this is just times -2, right? Oh, fuck. Sorry, give me 1 second. So if y'all want to pull up exam questions and stuff, we'll go through those as well. Yeah. Yep, we do have 2 columns. The solution would be 1 free variable in R2. Yes, but she asked about the span, right? I think that was right. What was that? The span is in R3. The solution set is in R2. All right. Yeah, here.
I have a. Can you explain the following sentence?
Okay, so the question is the following sentence.
The first entry in the product AX is a sum of products.
So the first entry in the product of AX, so something you do need to know is how to multiply matrices, right? Is the whole kind of idea that we build off of this stuff. So how do you do it? A times X. The way you check it is, we'll say A is M by N. X is N by 1. What you do is you draw this little box around the middle. They're the same, you can multiply, right? If they're not, you can't. So the way I draw it is you have A, this is your matrix A, and I put X up here. I teach this like a pre-calc teacher because I enjoy the way it's taught. Okay, so from here, this first column connects to this first row, second column to second row, and so on and so forth, okay? And then I draw this matrix down here, the same shape that kind of fits in there. And this first entry here is this times this, plus this times this, plus this times this, right? So that makes this a sum of products. Yeah. Are there any questions from like, let me check the chat. If someone can mute themselves, God bless you. General particular solution. Seven B, yeah, I'll definitely do that one because that was the one I was talking about. What is the difference between general and particular solution? General solution, I believe, is for X equals B, and particular solution is for when B is not equal to 0. Okay, questions? Yes.
So the earlier example with the matrix array, the 1, 2, -3, would the solution set be a plane and all?
So how many free variables do we have? Here. How many not pivots do we have? So we have this one as a pivot. This is a free variable then, right? So we have 1 free variable.
Okay.
So we have a 1-dimensional thing into the number of variables. So we have a line in R2. Cool. All right, so questions from past midterms, homeworks, stuff like that. Up there in the corner. Okay, which homework? 2.3 number 7. Okay. 2.3 number 7. 2.3 is the end of coverage for this exam, correct? Okay, 2.4. Okay, can you read the question to me by chance? Are these left, right, up, down columns? -6. Okay. Okay, so it's asking you to solve for which values of H will this have 3 pivots, right? Yeah, so what does it mean if it spans all of our 3? How many pivots do you need? 3. So we're going to solve this matrix to make sure it has 3 pivots, okay? The way I like to write it is, you'll notice that I wrote it out of order. This is A1, this is A3, and this is A2. I like to put my problem child in the back with this H, this last column. And then I always like my first step to be switching it so H is in the bottom. So when we start row reducing, -7, -6, -7h, and then top row becomes -2, -4, 3, 2, 3, 2. Okay, and then you're going to row reduce this to get it to a point that you'll have something that looks like number 0, 0, number 0. And let's say it's 2h minus 3. Okay, this is just an example because I'm not going to go through all the row reduction. So here, what do we need this to be? What was that? No, that is one of the most common mistakes I see with this question. This does not have to equal 1. It has to not equal 0. Those two things are not the same thing. Okay, glad you said that though, because that would have been like a lot of people do that, and I heard it a lot too. So yeah, so we solve 2h minus 3. We set it not equal to 0. You say it, you solve this exactly the same way as an equal sign. 2h not equal to 3, h not equal to 3 halves. And that is the only value of h that this isn't a pivot. Okay, so it'll say unless h is equal to 3 halves. Okay, that's how you solve some question like that. Something you should expect to see is a question with an h. You will always see that. That's on pretty much every practice midterm. It's been on your homework. It's been on your recitation stuff. You're going to see that. That's like one of those things, you know, over there. Oh, right in black. Yeah, my bad. Here, let me. Okay. Next question. What do we got? Yeah. Number 3 off of 2.4. What is this question? Okay, is there one in particular, 1 or 2 in particular? Because even when I pull this up on my computer, something that some of you may have noticed is between people, the true or false aren't always the same. They'll be shifted in order, and some people will have different ones. They pull from like a pool of questions for these. Because someone in chat repeated the definitions of general opportunity. What is the question? What question was this? This last one we just did. Okay. All right. So what was the? Okay. Yeah. 2.3 probably. I sure can. If anyone wants to go over any of the midterm solutions, those are much easier for me to do up here as well. So, like if you scan through some of the old midterms, see something that seems interesting or hard, and then we'll walk through it. So 2.3, what question did you say? Yeah. So this question is giving you 4 matrices, okay? And it asks, determine if they span R2. How do you tell if they span R2? Number of pivots. Yes, exactly. So you're going to row reduce each of these, which sucks. And then you count the number of pivots, and they'll tell you the shape. So if they have 2 pivots, they'll span all of R2, okay? So something else about shape that I failed to mention is if you span R to the 3, or 3 space in R3, you just say that you span all of R3, okay? You don't have to say you span a 3 space in a 3 space, because that's, who cares? Yeah. Yeah. So to have more than 2 pivots, right? This is saying in R2, so you have 2 rows. So could you ever have more than 2 pivots? No, exactly. That's a little trick there. Like that's a very hard thing that people don't make that connection very often. So there's not a way to have more than 2 pivots because you'll have a pivot here and you'll have a pivot here, and there's no way to get more. Okay. So whichever number, rows or columns, whichever one is smaller, that's your limiting number of pivots. Okay. Other questions? Yeah. Yep. Problem 2 on the most recent exam. Kowski. I teamed with Dr. Kowski last year. He's a good professor. He's at Berkeley right now doing some research. So yes, I will post the recording for this on Canvas. For spring 22, you said? Yeah, lovely. Calendar, we said which question? Problem 2. Very nice. Okay. Just give me 1 second for Edgeroom to work. Naturally. Any particular one of problem 2? No. Okay. That's fine. Come on. Inserts. There we go. All right. So question 2 is one of the short answer, true, false, that whole shebang. All right. So multiple choice and short answer. For the first question, 1A, I'm just going to breeze through these real quick. All right. If you have any questions, stop me, ask questions. So this one's yes and no. Is the equation x plus ln2 of y equal 4 a linear equation? Yes or no? Yes. The tricky part is that you see a natural log, but that's of a number. Natural log of 2 is equal to some constant. You do not, if you had ln of y, this would not be linear. A2 says is 2, oh, of course you know the answer. It's fucking solution. Anyways, A2 is the point 2, 0, 1 in the plane.
Yes.
Wow. The reason we know that is because you can plug in that point, right? And you'll get 2 minus 0 minus 1, and that's equal to 1. We know that to be true, therefore it's a solution. Okay. If you were that guy, you would put this equation into parametric vector form. You would find those vectors, and you would see if 2, 0, 1 is in the span of your solutions. And that is a different way to do it. That is much harder. So, but that's the idea of solution set. All of your solutions will be in your solution set, right? That's the whole idea. Do you have a question on this? I'll get there. Is it possible to have exactly 3 solutions? What are my 3 possibilities? 0, 1, infinity, right? There's not a way you can draw a fully functional space that has an absolute number of points. It's either infinite, it's a point, or it's not there. Yeah.
The last question, number 2.
Yeah.
Is the x minus y minus parametric?
Nope, that is a equation for a plane. So what you would do is you put that in a matrix. You're gonna augment it 1, -1, -1, augment 1. You're gonna solve it for parametric vector form. Then you're gonna see if it's in the span of the solution set. If you wanted to, don't do that. Just plug in the point and see if it works. Okay, make sense? Cool. B, write an inconsistent system of 2 linear equations and 3 variables, x, y, z. Inconsistent of 2 linear equations? Let's not make our lives any harder than we need to. Somebody give me the easiest things here. Yeah.
You do like 1, 1, 1, 0.
Too hard. Someone give me an easier solution. Yes. That's fair. That's exactly true. Okay, so what I would do is I'd give you 2 linear equations that look like x equals 1 and also x equals 0. Right? Another super easy way to get there. Don't overthink it, all right? You can do hard equations, but they just make the graders life a little bit harder. Just speaking for myself here. Which of the following matrices are in reduced row echelon form? You're going to have a question like this. You should know reduced row echelon form at this point, right? Check for pivots. You have a few qualifications. All pivots are descending in rows, right? So that means you have this nice stepper thing. Like here you see kind of like stepper down. There's nothing out of order, okay? All pivots are 1. All pivots are 1, and all entries above and below pivot are what? 0. Lovely. What are the answers to these 3? Yes, yes, yes. Okay, D, suppose an augmented matrix in reduced row echelon form has that in the bottom row. So if it has that in the bottom row, can you have any free variables?
Yes.
Yes, you can. Can the system be inconsistent? Why?
But it's in reducible echelon forms.
Yes, so this is the bottom row. So this is the furthest right pivot in reduced row echelon form. Because you got to have that stair stepper thing down, right? So you can't have anything further to the right if it's in the bottom row. Okay? Cool. System must be inconsistent, false. We need more information to determine whether it's consistent or inconsistent, also false. System must have exactly one solution. Why? Because it could have a free variable. We don't know what's above it. This could be the only row, right? Do we know that it must have infinitely many solutions? Why? Because it could not have a free variable. Oh, shit, I circled that. That's right. The system must be consistent, but we need more information to determine whether or not it's unique or infinitely many solutions. Correct. I had that written. All right, so that's that. Any questions about this? Yeah. This is from spring 22. This is the midterm they took. My bad. It happens though. So spring, the sample midterm 1, spring 22, Jankowski. Okay, the short answer. Complete the following mathematical definition of linear combinations. Is that the question you're looking at? Okay. So we already did one. So for that one, if it asks you to write the mathematical definition of linear combinations, x1 v1 plus x2 v2 plus blah 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 plus xv pv or vp equals b. That's a linear combination, right? That's the definition. What?
Write that out.
Yeah. So definition of linear combination. If B is linear combination of column A, that means x1 v1 plus blah 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 plus xp vp equals b. That is the definition, the mathematically rigorous definition of linear combinations.
You need to include the vector. They take off those.
I wouldn't, but it being correct semantically will never get you wrong. Who had a question that I pointed to and forgot about? Like, oh well, you had a question?
So if you write, like, for example, like W is the span of for that column, correct?
If you write a what?
Like something about span instead of.
Yeah, so this says that B is in the span of these.
So if I just write the span, like for example, like.
Yeah, so this is asking for the linear combinations, not span. That's the difference. Yeah, so this technically does end at 8 because that's as late as I can reserve the room, but I'm going to be here a little after as well, and we'll keep going probably until 8:15 or 8:30. But if anyone has to leave, feel free to go. I'm not holding you. This isn't required. I'm just here to make sure that you do better in your exam, however that means. Okay, so other questions, other midterm stuff. Yeah. Sample midterm or midterm 1? Sample midterm problem 3. Okay, so I'm going to read this to you to make sure I do the right question this time.
Like something like
3C.
Yeah.
Okay.
They start with suppose.
Suppose plane. Yep, that's it. Very cool. Okay. And that's not loading. Where the hell is this? Oh, okay. So this is a really good question. because it talks about the particular solution, right? This is a very tricky one that a lot of people messed up on. So if my iPad would work, I'd pull it up.
So exciting.
Dude, what the hell? Sorry, y'all. This has never taken this long for me before. Okay, so I'm just going to write this out because my technology stuff is not working. But this question states x1 minus 4x2 plus x3 equals 0 is the set of solutions to the matrix equation ax equals 0. Okay, this is saying this is the solution. And suppose that also the vector -3, 1, 2 is a solution. Nope. To ax equals 2, 1, 0. Okay. So going from here, how do we get the solution set from our equations? What do we do? Parametric vector form. We've already got all the matrix. So putting this in parametric form, we solve for the lowest variable, right? And here it's x1, because that's the lowest number. x1 equals 4x2 plus x3. x2 equals what? So this is our row reduced form, right? Oh, ha, I thought you were talking about minus x2, my bad. Okay, so x2 is equal to, and x3 is equal to. So the reason I like to write this out top to bottom is we just put parentheses around it and we're in parametric vector form, okay? So we write x2 and we write a vector 4, 1, 0 plus x3 -1, 0, 1. Okay. Following so far. Cool. So question I states, is it true that A 4, 1, 0 is equal to the 0 vector? Yes or no? Yes, why? Exactly, because this vector is within our solution set, 2ax equals 0, right? Therefore, yes. Okay, the second part, this was also one of the most missed questions for this when I did this last year. So this one asks, is it true that 1, 2, 2 is a solution to ax equals 2, 1, 0. Now what? 2, 1, 0. Okay, here's the whole lot of everything. So we know that -3, 1, 2 is a solution to this. Okay, so thinking about particulars, yeah. Yeah, so this is part I. Sorry, I should have clarified that. And this is part II. This is all given stuff. Let me see if my iPad wants to work real quick. Odds are no. And of course it doesn't want to work. Why on earth would it? Okay. Yeah, so this is all the given stuff up here. They give you this equation. They gave you ax is equal to 0. And they also give you this note that that is the solution to that. And then this is just what we found based on the given stuff. This wasn't actually any part of the question. So it asks if A 4, 1, 0, is that equal to 0? Yes, it is, because it's within the solution set, ax equals 0. 4, 1, 0 is. For the second part, it asks, is it true that 1, 2, 2 is a solution to ax equals 2, 1, 0? And we know this part, okay? So when we shift a span, when we shift things for a solution set, right? It's like you're taking a line and you're moving it, right? So the origin doesn't have to be exactly in one place. And what I mean by that is if I'm graphing, okay, and I shift this line from here to here, okay, I could shift it to this point here and it would create the same span, right? Or I could shift it to this point over here. Or I could shift it to this point over here. And they would all create the same line, right? So what this goes to say is VP doesn't have to be one thing, all right? VP has to be just one of the solutions, and then that's what it is. So in this particular case, what is our VP equal to? Anyone want to take a guess? -3, 1, 0. Okay, because it tells us that's a solution to the inhomogeneous set of equations. Oh yeah, it is. One of the things my professors told me when I first started teaching is never try to actually do arithmetic or write numbers in front of people because you'll almost always get them wrong. Yeah, so VP equals this. So what does that mean our solution set is equal to? Well, it's equal to x2, 4, 1, 0, plus x3, -1, 0, 1, plus -3, 1, 2. It's a constant, okay? So what is this question asking? It's asking, is it true that this is a solution? So what does that mean in terms of solution set? How would we word this question like that? Yes, but let's say that in terms of solution set. So what this question is asking is this, of course I'm not writing, of course I'm erasing what I want to be writing. Is this here in the solution set to this? That is what this question is asking, okay? How do we solve that? Well, we set it equal to it. 1, 2, 2 equals, I'm just going to copy this. Copy. Here, okay? So, how do we solve this? How do we solve this? The answer would be to use algebra, right? It's like half the word of this class. So we can move this vector over here, okay, VP. So we have 1, 2, 2 minus -3, 1, 2 equals x2, 4, 1, 0 plus x3, -1, 0, 1. Okay. So what is this stuff on the left equal to? Equal to 4, 1, 0. Interesting. So can we get to 4, 1, 0 from x2 times 4, 1, 0 plus x3 times -1, 0, 1? Yes. How? What are our x2 and x3 or have to be? X2 is 1, x3 is 0. Therefore, the answer to this question is it is true that that is a solution. Cool. Other questions? Yeah. Yes, this is the one I wanted to talk about. The last question on the midterm from last year, and then we'll call it formally after that. So this is a 3-part question. It's about as hard as it's going to get for y'all.
Wait. I have super simple question.
Yeah, go for it.
Okay.
No, you're good. Let me try to get my iPad working for this before we get going. So this one is from the solution, the sample midterm from last year, not the actual midterm from last year. I think spring 22. Okay, so what this question is asking, yeah.
If something spans R3, does it also span R2?
If something spans R3, this could also span R2. So that wording is a little confusing because you can't have R2 and R3. What you could say is there a plane in R3 that this doesn't touch? And no. If it spans all of R3, it gets everywhere in R3. There's nowhere it doesn't contain. Okay, make sense? Cool. All right, so this question gives you a matrix. A equals 2, 1, -8, -4, 4, 2. Okay, and it asks you to write the solution set for A equals 0 and plot it. And a second part, which we'll get to in a second. But part C, I think is a little easier. So first of all, let's row reduce this, right? Row linear algebra, row reduced echelon form. This is 7 from 22 exam. 1. Okay, so we row reduce this. We're gonna get 1, 1/2, 0, 0, 0, 0, 0, 0, 0. Okay. So what does our span look like for this matrix A? How many pivots do we have? How many rows do we have? So it is a in, there it is. Cool, so let's put this now in parametric vector form, right? So how do we do that? Yeah. Okay. So span is a line in R3. I'm just doing the last part first so we can just get to talking about the solution set of it all. So what this says, so now let's put this in parametric vector form. So row reduce, and then from the row reduction, put it back into equations, solve, put them in your vectors, you have solution set, right? So this is x1 plus 1/2 x2 equals 0. x2 is equal to x2. Simplifying this, we get x vector equals -0.51 times x2, right? Any questions about how to get there? Lovely. How do we plot this? You start at the origin. That's a great, yes, we do start at the origin. Then what? You go back 0.5 and up 1. Yes. Are we done? No, yeah, stretch it infinitely, right? So just follow it and keep going. If they ask you to plot it, my suggestion would be to draw it times +1, draw it times -1, have those points just like circled so we can see them, and then keep going. Okay.
That's the solution set of this.
This is the solution set. 2ax equals 0. So looking at this parametric vector form right here, do we know this is a solution set to ax equals 0?
Yes.
Why? There is no particular solution. This is plus, this is nothing. There's nothing there, right? That's why we know that this is the solution to ax equals 0. This, knowing that, is the whole answer to the second exam. Kind of. That's all we talk about for a solution set beyond this. Yes, so this is the solution set to ax equals 0. So what would this span? It would be a line in R3 and what that line would look like. So this question doesn't ask that, so that's why I didn't do it. But just as a little aside to that, shapes, 3-dimensional thing. Okay, so what is our pivot column? The first one, right? So we take this vector, okay? 2, -8, 4. So we'll do 2, -8, 4, okay? And it points out like this. And it goes back that way. And that is what our span looks like. A line in R3. You can probably understand why that's hard to draw, right? I don't believe so. I mean, if you do, just get close and label points. Yes, so this is the solution set to ax equals 0. The next part says for some b, the vector v equals 1, -1 is a solution. 2ax equals b. Okay. Do we have enough information to draw the solution set? And if yes, draw it. If no, say why not. Okay. So something to note. Can we get from our homogeneous solution set of -0.51 times x2 equal to 1, -1? How? No, right? There's no number we can multiply this by to get here. So what does that tell us? It is not in the homogeneous solution set. We can translate it. That's exactly right. So how can we translate it? There are a whole bunch of different ways to do it, okay? You add, that's a good, yeah. You're not wrong, I mean. So basically, there's an infinite number of right ways to do this. But what do we know B is? Or rather, what do we know B is not? 0, right? Because we can't get from here to here, but it says that it's a solution. So we would have had to shift our solution set to get there, right? So someone give me a number to set for x2. Easier than 1. 0. Yes. So solving this for 0 times -0.51 plus VP equals 1, -1. What does that make VP? 1, -1. So now we're plotting x2 times -5, -0.51 plus that. Okay. How do we draw that? 1, -1. There's our point. And from here, we count -0.5. And then 1 up from here. So this is -1. No, sorry. So we go like this now. Starting from there. So if you plot the two next to each other, it would look like this. 2 parallel lines. Okay? This is AX equals B for whatever that B is. This is AX equals 0. This is the hardest question they can ask you on the exam. I promise. They ask you anything with a particular solution, it is hard. It is not easy, it is not easy. Any questions about this?
There are always questions.
Unclear. They like to pepper it in sometimes. So be ready for it, but don't make it the main focus of your studying. Yes. Yeah. So again, just to walk through it again, what we did is we know it states that this is a solution. Okay. So it has to be some combination of this and this to get here. Okay. So we just set x2 to be equal to something, whatever we want to make it 0. Solve for VP and then we're there. Okay. Wouldn't that make what? It would, right? These go away, and then we have VP equals this. And that's what I just skipped this. That's just VP right there. Yes. I'll be hanging out here. You guys are welcome to come up and ask some more questions. Good luck in the exam, and thank you for coming. Yes. Yes. And one more reminder, because people keep asking, how do you find these practice exams? You Google Jankowski, or technically you Google Margaret as well. Jankowski, 1553, GodTech, you'll find his website. And then I also sent an announcement about it on one of my things. So, yep. Yeah, absolutely. Have a good night. I cannot do that. Just send me an email and I'll figure out some time to do that. No, here. Sorry.